Perfect. Okay, so here's what we're doing today. We're still dealing with the congruency stuff, right? Things are equal. You can set them up. You can set certain walls equal to each other or certain angles and solve for X, solve for Y, or A, B, and C like you had in the Google question of the day yesterday. So if you didn't solve the Google question of the day yesterday, remember it's due today, some point before midnight tonight. So you can kind of work on that. I think the goal in that one, you were supposed to see that the two triangles are equal. They give you the little letter system. We'll review that here in a little bit. I think it's like the second problem. We'll do that. Then you can set certain walls equal to each other. This will be a nightmare to edit. All right. Anyway, we're going to be setting certain walls equal. You solve for A, B, or C, and then what you have to do on that problem is you have to go plug those A, B's, and C's back in and tell me what each of those walls are on that triangle. So, this wall is this length, this wall is this length. That's what you have to do on that question of the day yesterday. I'll review it a little bit. We have a question that's pretty close. I think we have one with angles today, so you'll see it. But yeah, so it was based on congruency. It's based on this little object here. If things are equal to each other, then everything has to match. The walls, the angles, everything. And you just have to know which parts to set equal so you can solve. So that's what we're going to look at today. So I'm going to jump right in. I said I wasn't going to waste any time. We're going to get right to the problems. That way you get a little bit of time to work today on your little Google question of the day. But I also want to make sure that you understand what you're doing so you're not lost or anything like that. All right. Does anyone else need a calculator? Sorry, I better ask before we begin here. All right. For those two at home, can you guys put in the chat, can you guys hear me just fine? Hoping that you guys can. I didn't hear anything from you guys earlier. Sorry, I had the microphones muted. Everyone else is here. Excellent. Except for 2. All right. Okay, perfect. Thanks, guys. Sorry. I was taking attendance. Perfect. Good work. All right. Let's jump right in. On this particular problem, we can find X and Y really easy. Like this is a simple problem where you have the two triangles. These are actually physically connected to each other. You can actually transfer numbers around. This is something that was really similar to what we did, the 2 sections ago when we were doing, solving for X, solving for Y type of thing. So on this one, can anyone tell me how to find, any of these variables, any of these numbers? What's something we can do on this problem that's obvious? Okay, what do you got?
40 and Y is vertical.
Yeah, vertical. So if you don't remember what vertical is, it's a little funnel system. The 40 can transfer through the little funnel, which is called vertical angles, like you said. So the Y has to be equal to the 40. Vertical angles are equal to each other. We've talked about that. So that's how you find Y. Now, how this would work with the stuff we're doing today, like the new stuff that we're in. They could have told me, maybe these triangles weren't physically connected. They could tell me, certain triangles, so like, for instance, triangle, like ABC is congruent to triangle D or ADE or something like that. ADE, and maybe these are the letters. So this was A, this is B, this is C, and this is D and E. Now I had to pick the same letter because they were physically connected at A. So I can transfer numbers around from one picture to the other, that type of thing. So maybe the question is, what is angle D? Right? Maybe that's the question of questions. Okay. Perfect. Excellent. Thank you, Caden. I'll get you marked. Perfect. Thanks. Okay. Perfect. All right. So, okay. All right. Maybe that's the question. Maybe it's like find angle D. Now, I had a couple of people from not this section, but the later sections. They're really confused on the 3-letter system still. So maybe it didn't say angle D. Maybe instead it said angle ADE. That still confused some people. I think that was like 2 sections ago. When you look at that, I think that was the worksheet 4.2. That was the one that was due this past this past Thursday. I think it was yesterday. In fact, we had a worksheet due, right? They were confused on the 3-letter system. The middle letter is kind of the one that I look at. This is the letter I look at. So I'm finding angle D, right? It's saying A to D to E. So A to D to E. So it's this angle right here. This is what they want me to find, if that makes any sense. So I don't know why. It was just that it's been a while since we've seen angles like that. So I think that's what the part that confused them the most. So all right. Now what we're gonna do is we're gonna try to find it. So we found y is a 40, right? Because the little vertical, so good. Now, how do we find x? So how would we solve for x? Any ideas what we need to do here? How do we solve for x? So here's a little question. What do those little pink bubbles mean on that picture?
The same.
Yeah, those angles are the same, right? So the 2x that's in that little spot right here can be transferred over here to this location as well, right? They're the same 2x's. So now, how does that help me? What can I do there now?
2x plus 2x plus 4 equals 180.
Yeah, it's still a triangle, right? So according to theorem 4.1, the triangle still has to add up to be 180. So when you add the 2x's together, 2x, and then the 40, because angle y is a 40, right? We already know what angle y is. It still has to be a triangle, so it still has to add up to be 180. You still have to fall back to properties. Like, even though that property wasn't, since the first section, right? We're in the third section now. We still have to use that property. It doesn't go away. It's probably the most commonly used property when we get to triangles. So, to solve that, we'll subtract the 40 across, right? Subtract the 40 over, so we get 140 over here. And on the other side, I have 4 x's, because I can add the 2x's and 2x together. Now what? So now what do we do?
Divided by 4.
Divide by 4, right? Divide by 4. So if we get x, we divide by 4. So 140 divided by 4 turns out to be a 35 on the calculator. So that's my x, and that would be the angle. Now that we know that, now that we know what x is a 35, you can go plug it back in. And then we can answer the question in questions, right? The question is, what is angle ADE? Right, so we take my 35, go plug it back into my picture. So if I plug a 35 in here, that's 2 times 35, which is, what, 70? And then I can transfer those over to the other picture. Right, because everything in the pictures are supposed to be congruent. Angle B and D are the same, because up here, I can use this little chart up here. Angle B and D are the same, so I can transfer that around. This is also 70, so that can transfer to here. The other one is 70. C and E are the same. And they're both 70s because the 2x's are both the same. And I can transfer them, so there's my answer. So this question mark is 70 degrees. All right, questions with what we've done previously and how it's mixed with the new stuff. Okay, now,
Mr. Ward,
yes, question.
since we know that is 40, y is 40, and we know that those two angles are equal to each other, difference by 2, and wouldn't that just be this?
Hold on. I didn't understand one word you're saying right there. You're cutting in and out. You're kind of sounding like a little robot. You wanna repeat yourself there? Oh no, now I can't hear him. Bronson, how about you type it in the chat? I'll try to read through it. I know it's a lot of questions. Type it out in the chat because I can't hear you. Well, I didn't lose his connection. I think I have an idea what he's going to ask, but Bronson, I can't hear you. Your question, you had a good question, I think, but you want to type it in the chat or maybe try to. Oh, there we go.
It wouldn't. I was connected.
Yeah, you want to type out your question in the chat so I can read it, because I can't hear you. You're losing connection pretty bad. Okay, I think I know what his question is going to be. It's, did we actually really need to solve for x in this question? And technically it didn't. I think that's what his question is going to be, I think, if I'm predicting right. Because I know that finding x is fine, right? We could set that up. We could set up the problem like I did here, solve for x. You didn't technically need to do that. Here's why. The angle y is a 40, right? So if angle y is a 40, the other two angles have to be the same anyway. And so they have to add up to be 140. So both of them had to be 70. 70 and 70 makes 140. So you didn't really need to solve for x. We could have done it without the two x's sitting there. So I think that's what his question is going to be.
Yep, that's what I was asking.
There you go. I kind of predicted, yeah. So, yep. Yeah, it was a good question. Yeah, you could have done it that way too. So, yeah, you could have bypassed the whole solving for x idea and plugging it back in. Yep. I thought that was what the question was going to be. All right. Yeah, so it's valid. You didn't really have to solve for x. I just think it's easier. You don't have to really think too hard about the problem. But yeah, good point. Okay, questions on this one? That was good though. Good question. Okay, let's go on to the next one. This is the new one today. This is the one I want to focus on today. It's the second one. This is the whole purpose of what I want to do today. It's this one, okay? This one uses the theorem 4.3, which is the third angle theorem, which is that new theorem we've had in this section in the congruence. We didn't really use the third angle theorem too much, but now we're going to in this particular section. This particular problem, we have to use that third angle theorem. All right, if you want, I can put the little triangle congruence off to the side, but I don't think you need that on this particular problem. I think you can see what's about to happen here. All right. Okay, so let's talk about this one specifically. Okay, we're given two right triangles, right? One of the triangles has little pink bubbles. That means that those angles are the same. So, so what would the measure of this angle over here be? What's the measure of this thing? 52. Okay, we're going to use that fact here in a second. That angle has to be 52. So the 15x minus 8y. Ooh, I forgot the x. 15x minus 8y. That has to equal 52 because that little pink bubble allows me to do that. I didn't need to have that idea of like congruency to see that. They just have the bubbles. Okay. Then we have the 90. And now what is this other angle in the corner here? What is this angle down here? Do we know? What is that missing third angle going to be? 38. Yeah. It's going to be 38. Yep. This angle is going to be 38. Now, why? There's two ways to know this. Why is that 38? Why is that angle down there 38? Yeah. Triangle has to add up to be 180. You can subtract it from 50, or you can subtract 180, subtract the 90, and subtract the 52 and get the 38. That's one way. The other way, right? That's a good way. That's probably the way I would have done it without thinking even too hard about it. The other way I would have done it is that the remaining two angles here, these two angles have to add up to be 90. That's the other way, because again, it's a right triangle. The smaller angles in a right triangle have to be complementary. That was one of our theorems, or sorry, that was a corollary that we had. That was our first corollary in this section. So bringing back some old properties that we've seen in those first and second section. Now, why I say this is in this section, because it is. It's found in this fourth, or this third unit, right, on congruence. It uses the third angle theorem. On both triangles, the 90 and 52 are marked. So that means since both triangles have two angles marked the same, their third angles have to be the same. So this 38 can be transferred automatically to right here, even though there was no bubble present. It's the third angle theorem. Two angles of one triangle equal two angles of another triangle, then the third angles have to be the same. They have to be congruent to each other. All right, does that make sense? This third angle theorem. Now I'm gonna mark this down here. So I'm gonna write that. So the 6x plus 14y has to make the 38. Okay, questions on the setup on this particular problem? Now, how do we solve for x and y? Because that's the question on this one. This one, I think the directions in the book, I pulled this one from the book. It said find x and y. How do we do it?
Elimination.
Yeah, you can do it by elimination. Probably that's what I would do here. Probably not a substitution method. It's still a system, right? You have to stack the two equations. I actually just did it, right? Stack the two equations on top of each other. We have to pick one of the letters. So you can either pick x or y's. I don't really care. So this is going back to those days when we solved systems. That was back when we did the algebra stuff. So, say it again?
You should go with y.
Why is that?
Oh, because the signs are different.
Exactly.
Because you get 8 equal 14.
Yeah. Yeah, that's exactly right. So the reasoning for picking y is that the signs are plus and minus, they're already different. That's why I would pick the y as well. I don't have to do any extra work. I just need to make the 8 and the 14 the same number. I got to figure out what 14 and 8 both go into. 14 times 3. 14 times 4. They both go into 56. So 8 and 14 both can multiply to get to 56. So how you do that on the top equation, I'm going to multiply this top row by 7 to make the, again, we pick the y's here. I'm going to make that 8 a 56 by multiplying by 7. And on the bottom row, I'm going to multiply this bottom row by 4, and that'll make it a 56. Again, that just takes a little bit of calculation to figure out what do I need to make them. How I did that, I just literally just took 14 times 1, 14 times 2, 14 times 3, and then just try to figure out when it would equal something that 8 could go into. So I was thinking of 8, 8, 16, 24, 32, 40. I was just trying to think of numbers that 14 can go into. And eventually 56 was one of them. Now, going across, multiplying that top row by 7. 15 times 7, that's a really big number. So this top row, I'll try to keep it color-coded so you can see this. 15 times 7, that's 105 x's. Then I have the 56y, that's negative 56y. And then 52 times 7, because I have to multiply the whole row by 7, that's 364. Okay, so it's multiplying the entire top row by 7. I try to keep it color-coded. All right, what about the second row? What am I going to get? Somebody walk me through it. What are the numbers going to be? You guys all have calculators? What's my second row going to be? What's my x going to be on that second row? 24. 24 x's, right? That's 4 times 6. Keep on, you're on a roll. 56, because that's the whole point, right? We want to get the y's to be the same. And 152. Okay, so we got my second row again. That was that blue row. I multiplied everything by 4. Right. Now we don't need to change the signs. We can just add straight down. The reason why we can just add, the 56s were already opposites. They're going to cancel each other out. One was negative, one was positive. So I don't need to switch anything. So if I add straight down here, I'm going to get a 129x. The y's cancel out. That's what we wanted to have happen. And 364 plus the 152, 516. Now what? Yep. Divide by 129, divide by 129. So 516 divided by 129 turns out to be 4. All that work just to find out it was a 4. Now what?
Find y.
You had to find y. Now you don't have to go through that whole process again. You can just take your x and go plug it back in. I would go back up to one of my original equations, either the green or the blue one back to that original top equation, and just plug the 4, and what letter is the 4 going into? X's. So I'm gonna, I don't know, let's do the second equation. I like the second one a little bit better, the one in blue. I'm gonna go to that second equation, the one that had the 6x plus 14y equals 38. I'm gonna take the 4 and plug it into the x. So if I take the 4 and plug it in here, I'm gonna get 24 plus 14y equals 35. I would subtract this across. So if I do that, subtracting that across, which is, oh, I wrote that wrong. It was supposed to be a 38. What am I doing? I'm an idiot. Subtracting that across, I'm going to get 14. So that's 14y equals 14 if I subtract the 24 across. Sorry, I should write down my problems correct before I start them. Divide, and my y is a 1. All that work just to find y is a 1 and x is a 4. Questions with the setups here. Now, here's my question to you guys. Do you need another one of these to make sure you know how to do a system? Okay, I'm going to leave this on the board. How about I just do that? You have a Google question of the day today. I want you to attempt to try this one. This one will be a participation only. It won't be like I'm grading it for super accuracy. I just want to see if you guys can try this out. Okay, if you need a calculator, let me know. Caden, I know you walked in. Do you need a calculator at all? Okay, all right. Just making sure. The question you're going to have is based on a system, so you have to know how to set it up and solve. So it looks really close to these, so be aware of that. All right, I'm going to turn you loose, though. I'm going to stop the recording here. I'm going to have to edit this, so hopefully my camera